Hello, section 2.4, circumference and area of a circle. It's all been done before. It's done in the foundation course. It's done in Key Stage 3 from year 8 onwards. Bit revision. Circumference of a circle, 2 times pi times r. 2 radii make a diameter, so c must equal pi times a single d. And the area of a circle is pi times the radius squared. Okay, revision done. Now, a semicircular rug has a diameter of 75, so from there to there, right through the dog's neck at the end, comes to 75 centimetres diameter, notice. It is edged with fringing, so it's got a lovely little fringe there. It's obviously had a haircut, looks beautiful. Calculate the length of fringing needed to go all the way round the rug. Now, this is a really bad picture. You've got to go all the way round the rug. It's hard to know if it means just that bit alone. That's what the picture has. But all the way round the rug does include fringing back here, which you probably can't see. I'm going to do 2 calculations. Let's chop the dog up. I'm going to do 2 calculations, one with just this part and one with that part included. Okay, so I don't know what it says at the back of the answer book. I'm not going to look at that. I'm just going to do both parts. Right, what do we need to do? We need to work out the length of fringing needed to go all the way around. Well, that is not actually all the way around. All the way around means round the back as well. But let's just do this bit anyway. Essentially, it's the circumference of this entire circle, but it's only a semicircle. So let's just go for circumference. So c equals pi d. Put in the numbers, 3.14 times a d of 75. Get our answer. So machine. 3.14 times 75 equals, so I've got here so far 235.5 centimeters, so that's the whole circle. So semicircle, it's going to be 235.5 divided by 2. Just divide my answer by 2. I didn't cancel it on my calculator, and that gives me 117.75, and that's in centimetres. So that's how much fringing I need to go around this part alone. Now, if I need to go across this part as well, I want to add on the diameter. To go all the way around, you need 117.75 centimetres plus the diameter length around the back, so plus 75. Now, again, I don't know what the question's asking us to do. Clearly, I'm just adding on the 75 and getting this. I need 192.75 centimeters of fringing. Now, had this been in an exam, you wouldn't get a picture as fancy as that. You're probably going to get this part here, and they'll show you the fringing at the back. At the moment, this question will be taken 2 ways. Either this fringing I should calculate, in which case it's half a circumference, and or it could mean assume there's some more fringing at the back there, even though it's not drawn in. Either way, the answer is going to be either that one or that one with the extra piece of diameter fringing. Alright, so it's the best we can do at the moment. Next question. Right, lovely. What have we got here? I'm just doing 3 questions, I think, but it's challenging enough. This is question 10 with a little star, sunny star by in green, so it's hassle. And that was question 7, the previous one, by the way. This is question 10. Terry is training for a fun run. How can running be fun? I mean, look at it. She needs to run 10,000 meters each week during her training. Right, the diagram shows the running track where she trains. Terry says, if I run 5 times round this track each day, from Monday to Friday, I will have run more than 10,000 meters in a week. Is she correct? Show you're working. If you just say, yeah, she's correct, no, she's wrong, you know, expect 0 marks. You've done nothing for your marks. You've got to do some working out. Essentially, if you're running around the track, you want to run around here, and here, and here, and here, and you're back. What do you see? Well, I've got 2 straight sections, 120 meters each. I've also got half a circle here and half a circle there. Now these 2 halves make a whole circle. and that whole circle has a diameter of 50 meters. Alright, well let's just work out the circumference or the perimeter of this track. So we're going to assume Terry's going to run around the edge and really do the full thing rather than just running around on the inside and do less of it. Alright, so we have to assume this 50 relates to the distance across here and here, and we'll include these two 120s when I add them on to be, you know, part of the whole track. Alright, so these are my assumptions that I've made. So let's just take a look. I've got circumference is going to be pi times d, which is 3.14 times 50. Now that takes care of the two semicircular halves. Let's try and draw it in then. That one and that one. Beautifully drawn. So that's going to be 3.14 times 50. That gives us 157 meters. So length of track is going to be 157 plus 120. Stop it. Plus another 100. Oh dear, plus another 120. If you'd let me do this, I'll be really happy. Plus 120. This is the full track. Here we go. So plus 240 onto that. That gives me, there you go, it's right, it's 397. Essentially it's a 400 meter track, but the maths won't let me push it up to 400. Right, she's going to run 5 times round this track each day from Monday to Friday. So that's 5 days times 5 times. Ah, okay then. So total run is going to be 5 times over 5 days, and that will give us, if I press that now, that's going to give me, so look, 5 times 5, yeah, let's just do that. Right, so that's going to be 25 times 397. Should be 400 really. What does she get? That gives us 9925 meters worth of stuff. Ooh, she doesn't quite make it, does she? If that was a 400 meter track, let me just work this out myself. So 25 times 400 equals, well, look at that. If it was a 400 meter track and I could make it, you know, more than that and lift it to 400, that would be exactly 10,000 meters. Now Terry's saying I would have run more than 10,000 meters in a week, and we have to say, is she correct? We say Terry is wrong. Oh please, Terry is wrong. I have to pause this. Right, conclusion after coming back to you now. So Terry is wrong. Semicolon. She runs less than 10,000 meters in the week. She says she can run more than 10,000. No, she's actually going to run less. So that's that one then. Right, we're going to do some cake now, aren't we? Right, this is question 11. A circular cake tin has a diameter of 22.5 centimeters. So from there to there, you've got a lovely 22.5. I mean, you can't see that very well, but it doesn't matter. The lid is sealed with the tape. There's the tape there. And the ends of the tape overlap by 1.5 centimeters. I think you just about see it, can you? So from here to here, that's an extra 1.5 centimeters. Oh yeah, from there to there. Let's just draw it in, and that's significant. Calculate the length of tape around needed to seal the tin. Alright, let's just do it. Essentially I've got a whole diameter plus a 1.5. Let's do it in one step. So length of tape needed is going to be pi times the diameter, 22.5, that gives us a full circumference, plus an extra bit of 1.5 just to stick it down with whatever glue they're using. So straight in now, that's all it requires. 3.14 times 22.5 plus 1.5. Altogether, I need 72.15 centimetres of tape needed, and that's all there is to it. I'm going to stop there, and that's your revision done with circles, and I'll look at 2.5 in a minute.